Right now, somewhere out in deep space, a black hole is stretching a full star into thin glowing noodles, not burning it, not smashing it, slowly pulling it apart like soft taffy being stretched by hand across the room. A telescope right here on Earth just caught this strange meal happening in real time, frame by frame. This is the strangest dinner party in the universe, and for the first time, we have a front row seat. If your brain lights up for moments like this, the kind where the universe quietly breaks its own rules, stick around, hit subscribe, and tap the bell so you never miss a story this weird hitting the news. Most stars live very boring lives when you really stop and think about it. They sit quietly in their galaxy for billions of years, burning fuel, shining in a steady way, and slowly running out of energy. Then they begin to puff up and cool down. Some of them eventually fade quietly into a small, dense star called a white dwarf. Others blow up into a brilliant explosion called a supernova. Both endings are dramatic, yet both of them are well known to science. We have good models for how they happen. We have watched them again and again across many distant galaxies with our best telescopes. Black holes sound scary, but most black holes in our universe are actually very quiet. They sit at the center of large galaxies, including our own Milky Way, and they simply wait. A black hole is a place where gravity got so strong, so crushing, that not even light can escape from inside it. You cannot see a black hole directly with any kind of telescope we have today. You only know it is there because of how it pulls nearby gas and stars around in circles. You also know it is there because of the bright light the gas gives off when it falls in toward the center. When something drifts too close to a black hole, gravity can pull it in. Most of the time, the black hole slowly nibbles on passing gas, dust, and small bits of matter floating through space. That is normal. That is gentle feeding, kind of like a cow chewing grass in a quiet field. But sometimes, every now and then, something rare and violent happens. Every few 100,000 years in a typical galaxy, a full star, an actual sun-sized star, simply wanders too close to the center. The black hole grabs it, and what happens next is one of the most violent things we have ever watched happen in the whole history of science. Astronomers give this kind of event a long, complicated name. They call it a tidal disruption event, often shortened to TDE. The name sounds like a hard chemistry exam, but the idea behind it is actually very simple. A star gets stretched until it breaks apart. This happens because the pull of gravity on the near side of the star is much stronger than the pull on the far side of the star. Tides on Earth work exactly the same way. The moon pulls more on the side of the ocean that is closest to it. That is exactly why we have ocean tides flowing in and out every single day. A black hole does the same kind of trick to a star, only the stretch is so unbelievably stronger that the star cannot possibly survive it. For a long time, scientists thought these events were rare, fast, and almost impossible to catch in the act. A star normally takes about a year to be fully torn apart and eaten by a black hole. The bright flash of light that happens when the star breaks apart usually fades within just a few months. By the time most telescopes could swing into action and start collecting data, the show was already over. We would see the leftover glow and nothing more, kind of like walking into a kitchen long after dinner and finding only crumbs on the table. Scientists never really saw the meal itself, only the mess it left behind. Then in 2019, something happened that changed the way we witness this cosmic violence forever. A group of telescopes, including several run by the European Southern Observatory, caught a star being shredded by a black hole in real time. The event was given a name AT2019QIZ. It sits about 215 million light years away from Earth in a spiral galaxy in the constellation Eridanus. That is far, but it was the closest tidal disruption event ever recorded up to that moment as an early catch. For the first time in human history, scientists could watch a star brightening, breaking apart, and falling into the black hole, almost like watching a time-lapse video of a candle burning straight down to nothing. Now, here is something worth pausing on for a second. If a black hole just sits in the dark, how did the scientist even know the star was being eaten at all? Drop your guess in the comments below, and if this kind of real hands-on space science is your thing, give this video a like to help more curious people find stories like this one. Astronomers gave the stretching process itself a fun nickname. They call it spaghettification. The star does not get crunched up like a paper ball thrown into a fire. It gets pulled into thin, long streams of glowing material like noodles of light swirling in slow circles around the black hole. About half of the star's gas gets flung back out into space. The other half spirals inward, finally disappearing past what scientists call the point of no return. That point is called the event horizon. Once anything passes that line, no signal can ever come back out into the universe. Not light, not radio, not heat, not any kind of message we could ever build in the future. What surprised the team studying AT2019QIZ was not just how bright the flash was, it was how cleanly the data matched a pattern they had worked out in computer models years earlier. The old model said that when a star gets torn apart by a black hole, the light should rise quickly, reach a peak, and then begin to fade. That is exactly what we saw in the data. But the team also caught something the old models almost never showed so clearly in real measurements. They watched pieces of the star falling back onto the black hole, wrapping around it, and forming a glowing disk of material that flared and dimmed in step with falling gas rains. It was the first time the theory and the measurement danced together so well in public. Just a few years before that, in 2014, another event had already hinted that something powerful was hiding in this kind of science. The All-Sky Automated Survey for Supernovae, a wide-eyed robotic network of telescopes that scans the entire sky for sudden flashes, spotted a bright sudden flash in a small galaxy called PGC 043234 on November 11, 2014. The flash was later named ASASSN-14Li. Within a few weeks, scientists confirmed it was another star being torn apart. The galaxy sits about 300 million light years away from us, so far that we only see it at all because the act of eating lit the black hole up like a flare in the dark ocean of space. What made ASASSN-14Li special was not just the star itself. It was what the star left behind once it was gone. Within weeks, scientists noticed the black hole at the center was getting stronger, as if the star's death had given it fresh energy to act on. It was eating at a furious pace, much faster than it normally does on average over long periods of time. And in the middle of that meal, something completely unexpected came flying out of the black hole's vicinity. Bright streams of particles shot into space at nearly the speed of light. We could not see them with our eyes. We could only read them through telescopes tuned to radio waves and X-rays. We still do not fully understand why those jets appeared or what really fired them up. That part of the puzzle is genuinely still open today. Here is why all of this matters in everyday plain language. A black hole pulling in a star is the closest thing we have ever had to a controlled experiment on a real black hole. We cannot travel to one. We cannot poke it or touch it. We cannot put one in a lab and study it directly. So every time a star happens to fall into one, we get an automatic experiment, and we get to study what black holes really do just by watching. Each event teaches us something new about gravity, something new about how galaxies grow, and something new about how the universe handles its biggest, most dangerous ingredients. Some researchers compare it to watching a volcano erupt from a safe distance and learning how the planet works by carefully measuring what flies out of the crater. Right now, the story is not over. Tidal disruption events keep being spotted year after year all around the sky in different galaxies. In 2023, a new event named AT2023CLX became the closest tidal disruption to Earth to be found up to that point. And it sits around 300 million light years from us, so still very far away, but close enough that some of the world's most powerful telescopes could pile in and watch it almost from start to finish. And as of mid-2025, more papers from the James Webb Space Telescope team have confirmed something earlier groups had only suspected. Many tidal disruption events are hidden behind thick clouds of dust in their host galaxies, and they have been glowing quietly for years, just waiting for a sharper eye like JWST to spot them at last. For the first time in history, the James Webb Space Telescope has actually looked at these events through the dust and seen what is happening behind it. In July of 2025, an MIT-led team announced that JWST had observed multiple tidal disruption events hiding in dusty galaxies that earlier sky surveys quietly missed. Their analysis suggests that black holes can sit in deep silence for years, slowly feeding on a star, and then suddenly bloom into a flare bright enough for us to spot from Earth. A large fraction of these new JWST discoveries, somewhere around 30% of them, did not match the old expected behavior at all. That gap is exciting. It means the old story may have been missing close to half of the real picture. And that is the part most people miss when they read about black holes online. Were you expecting these giants to eat stars quietly in secret, or were you expecting them to throw out bright fireworks into space? Comment your honest guess below, and if you have not yet subscribed, this channel lives on stories like this one, real science without exaggeration, so why not join now and become part of the crew? Each of these flares, then, is a kind of flashlight pointing at a black hole that was hiding in plain sight. Before these events were caught in real time, we mostly knew about black holes that were already busy feeding on lots of material. Those are the loud ones, sitting at the centers of bright, glowing galaxies that everyone can see with a backyard telescope. Now we are starting to find much quieter ones, the silent middleweights in galaxies that do not shine anywhere near as brightly. This is huge because it means there are probably many more black holes in the universe than we ever thought, just sitting in the dark waiting for a star to fall in. The Milky Way itself might have millions of black holes that nobody has ever noticed. Most are tiny, way too small to ever reach in any meaningful way, but the mid-sized ones, the kind thousands of times heavier than our sun, those might be scattered nearly everywhere we look. Every tidal disruption event is one of those mid-sized black holes waking up out of a long, quiet sleep. There's also a quietly practical side to all of this science. Tidal disruption events are useful as cosmic measuring tools because we know the basic physics of how a star gets torn apart. We can calculate how bright the flash should be when we see it. If the flash is brighter or dimmer than expected, that small difference tells us exactly how far away the galaxy actually is. Astronomers have started using these flashes as a kind of standard candle, in the same way that old sailors used bright stars to navigate across unknown oceans. A few years ago, this was just a fun side project for one or two research groups. Now it is becoming a real tool used in published research papers and applied to surveys of distant galaxies that used to be hard to measure at all. None of this changes what we already knew about our own solar system. The sun is safe. Our planet is not in any danger of falling into a black hole. The nearest real monster black hole, the giant sitting at the center of the Milky Way, is about 26,000 light years away from us. Our star has been circling peacefully in its quiet arm of the galaxy for billions of years and will keep doing so for billions more. but the work still really matters because the universe is teaching us how to read its danger signs in real time. If something ever did change out there in some distant future, understanding these events would be the very first step toward understanding what was actually happening and why it was happening. And there is something quietly breathtaking about all of this when you stop and actually think about it. A star dies, and in dying it lights a black hole's lamp so brightly that humans can see the flash from hundreds of millions of light years away. The light we see tonight left those galaxies millions of years ago. By the time the light reaches our telescopes, the original star is long gone. We are catching echoes from an ancient meal, and yet we are still actively learning exactly what it means. In some ways, every telescope pointed at a tidal disruption is also a kind of time machine, letting us look back into a death that already finished before our species ever existed at all. Pause for a moment and really think about this. Do you think black holes swallow stars all at once in one quick gulp, or do you think they pick at them slowly, piece by piece, the way AT2019QIZ seems to suggest? Drop your answer in the comments below, and if you are watching this far, you clearly enjoy the deeper side of science. Hit subscribe so the next big moment in astronomy lands on your feed the moment it shows up. One big question that is still completely open today is why some stars break apart in tidy, predictable ways while others do something totally wild. In AT2019QIZ, the data lined up almost perfectly with the expected pattern of a slow rise and fall. In ASASSN-14LI, the black hole was firing out high-energy jets nobody fully understands even now. In JWST's hidden events, the flares took years to grow bright and stay visible instead of peaking in just a few weeks. It is the same basic event, but three very different versions of behavior. The black hole's size, the angle the star came in on, the speed of the original orbit, and the amount of dust and gas around the black hole all seem to change the result in ways we are still working to understand. That is a lot of moving parts for one cosmic recipe, and a lot of unknowns that future telescopes will likely help us sort out piece by piece over the next decade. Here is the simple version in case all of this feels a little overwhelming. Every few decades or so, somewhere in the night sky, a black hole tears a wandering star to pieces. We can now spot that flash with powerful telescopes on the ground and in space. Then we can study it again and again from start to finish with new instruments that did not even exist just 10 years ago. Each cycle teaches us more about the universe than the last one did. Each cycle closes one mystery and opens two more. The story of black holes has not finished yet because the universe has a very long memory and an even longer appetite for matters of this scale. Zoom out for a moment and think about what this actually means for science as a whole. This is what astronomy looks like in 2025 and beyond. We are not just taking pretty pictures of distant galaxies anymore. We are catching real cosmic events in real time, the way you might catch a serious event happening in your own city by listening to the alarms go off, counting the small details, and trying to make sense of the trail left behind. We are watching gravity itself perform in slow motion in deep space. We are watching the universe lose its grip on a single star and pull it across the line. This is what real science feels like when it actually works. It is not finished, it is not clean, it is just real, and that is exactly what makes it so exciting and worth following for years to come. And if you ever stand outside on a dark, quiet night and look up at the sky, remember this. Several of those tiny pinpoints of light out there are likely the centers of distant galaxies, and inside each one there might be a hungry hidden black hole. Some of them might already be in the middle of a tidal disruption right now, this very second. Their light has not reached us yet, and a million years from now, if someone is still around with a powerful telescope, they might catch the exact moment we cannot see today. It is okay to feel small compared to all of that. It is also okay to feel proud of the fact that humans in just a few hundred years of serious science managed to figure any of this out in the first place at all. And here is the part that hits hardest of all to think about. If we could somehow peer through our own Milky Way's dusty center, would we see a quiet giant sleeping peacefully? Or would we see a sleeping one that is finally ready to wake up? Comment what you honestly think, and if you want to keep learning these kinds of true stories that nobody is exaggerating, turn on the subscription bell and be the first to hear about the next big discovery. So to bring it all together in one place. In 2019, AT2019QIZ gave us our first clear movie of a star being stretched into thin glowing noodles and pulled into a black hole about 215 million light years from Earth, watched by telescopes run by the European Southern Observatory. In 2014, ASASSN-14LI showed that the leftover material from a torn star can shoot out into space in fast streams of particles that we still do not fully understand yet. In 2023 and 2025, new telescopes like the James Webb Space Telescope started finding more of these events hiding in dusty galaxies than anyone had predicted, suggesting a big fraction of all tidal disruptions may have been invisible to us until now. Each year adds more pieces to the puzzle. Each new discovery keeps quietly redrawing the picture of how black holes grow, how galaxies evolve over deep time, and how the universe balances its most extreme ingredients over billions of years of change. This is not a closed chapter at all. This is a story still being written, with the next chapter almost certainly to come from a telescope we have not even fully used yet, or from a discovery nobody on Earth is expecting. Maybe next time we will catch a tidal disruption close enough to map out the inside of the flare in detail. Maybe we will catch one that completely breaks every model we have today. The universe has surprised us before, and it will certainly surprise us again. We are watching that surprise unfold in real time, and there are likely thousands of these quiet events waiting out there in the dark, ready to test us the very moment we point our best instruments at them. If this kind of deep, slow-moving real science is your thing, hit subscribe and tap the bell so you are the first to hear the next story as soon as it drops. Drop a comment answering one simple question. If you could only watch one more tidal disruption event from start to finish with all the best telescopes pointed at it, what would you most want to see? Share this video with someone who loves these quiet, vast, real-life mysteries. They will thank you for it, and so will the universe in some small but real way. Thanks for staying with us right through to the very end. We will see you right here in the next one.